Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In this lecture we will do some extra questions based on factorization of polynomials as well as algebraic identities to factorize the polynomials, right. So these extra questions will boost your confidence in this chapter. So let us start with the first question here, which is factorize each of the following algebraic expressions. The first one is x raised to power 8 minus y raised to power 8. Now this can be considered as x raised to power 4 squared minus y raised to power 4 squared. Now I know this identity, a square minus b square is equal to a minus b into a plus b. So this is the identity I will use in the first part of this question here. So this will be x raised to power 4 minus y raised to power 4 into x raised to power 4 plus y raised to power 4, right. Now this is again in this form, a square minus b square. How? X square whole square minus y squared whole square into x raised to power 4 plus y raised to power 4. So this can again be written in the form of x square minus y square, x square plus y square into x raised to power 4 plus y raised to power 4. Now you see this can again be factorized, x minus y into x plus y, and this will remain as it is, x square plus y square, and then this x raised to power 4 plus y raised to power 4. So this is the factorized expression for x raised to power 8 minus y raised to power 8. The formula I used in this is a square minus b square is equal to a minus b into a plus b. The second part is a raised to power 12 x raised to power 4 minus a raised to power 4 x raised to power 12. So I can take a raised to power 4 into x raised to power 4 common from these two terms. So the first term will be a raised to power 8 and the second one will be x raised to power 8. Now this is pretty simple because we have just solved such a question, x raised to power 8 minus y raised to power 8. So the factorization of this I will write directly because I already factorized it, okay. So I will write a raised to power 4, x raised to power 4. Now the factorization of this will be a minus x, a plus x, a square plus x square, a raised to power 4 plus x raised to power 4. I am copying it from this expression which I just solved for x raised to power 8 minus y raised to power 8. In case of examination, if you get this question separately, then you need to show the process for this factorization also. In this lecture, I can take the liberty because I just solved such an expression. So this will be the factorization. Factorize each of the following expressions. Now the first expression is 4a square minus 9b square. So if I write it like this, 2a whole square minus 3b whole square and then minus 2a minus 3b. Now the first part, that is this part, is a square minus b square type. So I can write it as 2a plus 3b into 2a minus 3b, and this, if I take minus sign as common, 2a plus 3b, right. From these two terms, this one and this one, I can take 2a plus 3b outside, and inside I will have 2a minus 3b minus 1. This is the factorized form of this expression here, okay. In the second part, I can see that this is the expression for x plus y whole square. So x plus y whole squared, and if I take negative as common, this is a square minus 2ab plus b square, right, which is the expression for a minus b whole square. So x plus y whole squared minus a minus b whole square. So if I consider it, let us say m and this as n, the expression inside the bracket as m and n. So I can say m square minus n square, hence is equal to m minus n into m plus n. The same formula that we told you in the beginning. So it will be x plus y plus a minus b and x plus y minus a minus b. So it will become minus a plus b, right? And this is the required factorized form. In this one, if I take 3 as common, inside I will have 1 minus 4 a minus b whole square. Okay. So 3 is outside, 1 can be written as 1 square and 4 is 2 squared. So 2 a minus b whole squared is the expression for this, 4 a minus b whole square. Alright, so again in this bracket I have got an expression of the form m square minus n square. So I will write it equal to m minus n into m plus n. So 3 into 1 minus 2a plus 2b, right? And in the second part I will add it, 1 plus 2a minus 2b. Okay, and you need to do this carefully because you need to take care of these signs. When this negative sign is there, so negative negative will be plus 4b, as in this case, right? When this will become positive, then it will be negative sign for b. Okay, so you take care while solving this question, take care of the sign, and this will be the factorized form. Look at this one, x into x plus z minus y into y plus z. Now if I expand it, x square plus xz minus y square minus yz, right? Because of this negative sign it will be minus yz here. So if I separate and group these terms like this, x square and y square together, so x square minus y square, and these two terms together, so I can take z as common and x minus y will be inside. Now x square minus y square can be written as x minus y into x plus y and then z into x minus y here. If I take x minus y common, inside I will have x plus y plus z. Okay, this is how you will factorize this expression. So first thing that we expanded this expression, we multiplied it inside the brackets, and then we saw that these two terms can be clubbed together and these two terms could be clubbed together, so we proceeded in that way. Factorize each of the following rational expressions. So this is x raised to power 4 plus 4. Now if you look at this expression carefully, this can be written as this, x square whole square plus 2 squared, right? Now think about this, I have got a square plus b square type of term. If I add 2ab in it, it will become complete square. Now if I add something, I will have to subtract the same thing to keep the expression same. So that is what I am going to do here. I will add 2ab and then I need to subtract the same thing, which is 4x square, right? Now this expression is same as this one. Now moving on, the first three terms when clubbed, these three terms will make a perfect square, that is x square plus 2 whole square and minus, this can be written as 2x whole square. Why I am writing it like this? Because I wanted it to be in the form of a square minus b square type, right? So that I can write a minus b into a plus b, which is what I am going to do here. X square plus 2 minus 2x, x square plus 2 plus 2x, right? Now this is the required factorized form. Okay, I have factorized this expression in two factors, these. Okay, look at this expression carefully. First of all, try to convert it into perfect squares. X square squared, and then you have got 3 here, but here I can have 2 into x square into 2, right. Why I have written it in this form? Because I know that a square plus b square plus 2ab is equal to a plus b whole square. Now I have got something squared, a squared, x square squared. So here I will have 2ab, so 2 into x square I can write here, and then this will act as b. So what I need here to make it a perfect square is 4, which is 2 squares, okay. But I have got 3 here, so I will subtract 1. So now look at this part, these 3 terms. This is just the square of x square plus 2, and then you need to subtract 1. 1 can be written as 1 square, so this is a square minus b square type, hence I can write it as x square plus 2 minus 1, x square plus 2 plus 1. So the first part is x square plus 1, and the second bracket will give me x square plus 3. Okay, this is the factorized form here. Factorize each of the following expressions. Now we can also use middle term splitting in factorizing because these are quadratic expressions. So I will try and split the middle term. Now look at these two. The product of these two, that is 4 root 3 into 2 root 3 is root 3 into root 3 is 3, 3 into 2 is 6, 6 into 4 is 24. Now I need 5 here. 5x has to be split in a way that the two terms that will be there has a product of 24x square. So I can easily split it into 8x and 3x. So 4 root 3 x square plus 8x minus 3x minus 2 root 3. Hence from these first two terms I can take 4x common. So I will have root 3x plus 2, and from these I can take minus root 3 common, so that I have root 3x plus 2 inside. Okay. So the factorized form will be 4x minus root 3 root 3x plus 2, right. So this will be the factorized form. So I have used middle term splitting in this. I saw that the product of these two terms 4 root 3 into 2 root 3 is 24. So I wanted to split this in a way so that the two parts have a product of 24. Okay. Similarly in this one the product of these two terms is 5 root 5 into 8 root 5. This will make a 5, 5 into 5 is 25, 25 into 8 is 200. So I need to produce 200 out of the two parts that I split 30x into. So it is easier one, 5 root 5 x square plus 20x plus 10x plus 8 root 5 here, and from these two parts I can take 5x as common, so that inside I will have root 5x plus 4, right. So I need to produce root 5x plus 4 in the second part also. So what should I take as common? I can take 2 root 5 as common, so that I have root 5x here and plus 4 here. Okay. So now it can be written as 5x plus 2 root 5 into root 5x plus 4. Okay. So this is the factorization using the middle term splitting. Okay. All right. So now in this we will see this product 7 root 2 into 4 root 2, that is 7 into 4 is 28, 28 into 2 is 56. So out of this I need 56. 7 root 2 x square, 10 can be written as 14 minus 4, right. So this is how I will write it, minus 14x plus 4x minus 4 root 2. Okay. So this can be written as if I take 7 root 2 as common, so this will give me 7 root 2 x as common, so this will give me x minus, now I have taken 7 root 2 out of 14, so it will have root 2 only, and from the second part if I take 4 as common, it will give me x minus root 2, right. So if I take x minus root 2 outside, I am left with 7 root 2 x minus 7 root 2 x plus 4. So this is the factorization. Alright, let's move to the next one. Factorize each of the following expressions by splitting the middle term, right. In these expressions, inside the brackets it is given x minus 2y. So what I am doing here is I am replacing x minus 2y with another variable, let us say t, so that this question looks simpler now, and the question will become 9t square minus 4t minus 13. Okay. Now it is easier to visualize this question. So the product I need is 13 into 9, and the difference of 13 and 9 is 4. So this term can be split like this, minus 13t plus 9t minus 13 here. So I can take t as common, 9t minus 13 plus 1, 9t minus 13, hence the factorized form will be t plus 1 into 9t minus 13. Okay. Now the answer cannot be in terms of t, because t means x minus 2y. So let us replace t by x minus 2y back. So x minus 2y plus 1, 9 into x minus 2y, that is 9t, x minus 2y will be 9x minus 18y, right. So 9x minus 18y minus 13. Now this is our answer. Okay. Similarly, in this part I can replace x plus y by a new variable, so that this question looks simpler. Otherwise you can directly calculate, if you can think x plus y as your variable. Okay, you can directly calculate it, but if you replace it by a new variable, then this will start looking simpler. 2t square minus 9t minus 5. Now 2 into 5 is 10, 9 can be split into minus 10 plus 1. Okay, 2t common, t minus 5 plus 1, t minus 5. So it will be 2t plus 1 into t minus 5. Now finally, to write the answer, we cannot write the answer in terms of t. I need to replace t by x plus y. So the answer will be, I am replacing t with x plus y. So 2t will become 2x plus 2y and then plus 1, and t will become x plus y and minus 5 here. So this is the factorized form. Okay. In this one, we have got a plus 1 and b plus 2. So let us consider a plus 1 as x and b plus 2 as y. Now let us see how the question looks. 8 x square plus 2 xy minus 15 y square. Right? This is how the question looks now. Now look at this. If I split this term in a way that I get the product 8 into 15. So the product I require is 8 into 15. Okay, and I need to split this 2. Okay. So 8 into 15 can be written as 2 into 2 into 2 into 3 into 5. Okay, and I need a gap of 2. So I need two factors with a gap of 2. Either their sum is 2 or their gap is 2. So in this case, the gap should be 2 because I have got a negative sign here. So let us see. If I club these, it will give me 12 and these two will give me 10. So 12 into 10 should be the way how we split this 2. plus 12xy minus 10xy minus 15y square. Okay. Now out of these first two terms, if I take 4x as common, it will give me 2x plus 3y, and out of these two terms, if I take minus 5y as common, it will give me 2x plus 3y. So the factorized form in terms of x and y is 4x minus 5y into 2x plus 3y, but we cannot leave our answer in terms of x and y because originally it should be in terms of a and b. Okay, so always look at the original question before writing the final answer. X should be replaced by a plus 1, y with b plus 2. So 4 into a plus 1 will become 4a plus 4 minus 5 into b plus 2 will become 5b minus 10. Okay, if you replace y with b plus 2, minus 5 into b plus 2 will be minus 5b minus 10. That is why I have written it here. So this will be in the first bracket. In the second bracket, 2x plus 3y. So 2x means 2a plus 2, and then plus 3y means 3b plus 6. Okay, simplifying it further, 4a minus 5b minus 6, 2a plus 3b plus 8 is the factorization. Okay. Prove that 0.87 into 0.87 into 0.87 plus 0.13 into 0.13 into 0.13 and divided by this expression here. Now to look at this expression, if I replace 0.87 by some variable, that is a, and 0.13 by a new variable, that is b, then it will be easier for me to look at this question. Why? This product I can write as a cubed now, and this I can write as b cubed. Okay, this is nothing but a square, this is b square, and this is minus ab. Okay, now look at this. This is of the form a cube plus b cube, and what is a cube plus b cube? We know the expression for a cube plus b cube is a plus b into a square minus ab plus b square, right? We know this expression. So the term in the numerator can be written as a plus b into a square minus ab plus b square, and the denominator is already of the type a square minus ab plus b square. So now these can be cancelled and the answer will be a plus b. Now a is 0.87 and b is 0.13 and their sum is 1, which is the right hand side, right? Hence proved. So I considered 0.87 as a, 0.13 as b, and then using this formula here we solved this question really easily. Resolve this into factors. So a cube minus b cube. Now consider it like this: a cube plus negative b cubed, then plus 1 cubed. So it is sum of 3 cubes, right? Plus 3 into a into, if I need to write minus b here, then this sign will become negative, right? So let us make it negative here. Minus 3 into a into negative b into 1. Now you can see that I have written this expression in this format, and which is because I wanted to make use of this formula: a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, right? So let us use this formula here. Now a plus b plus c means a minus b plus 1, and a square minus b square is b square, 1 square is 1, right? Minus ab, so a into negative b, so it will be minus ab will become plus ab now, right? Minus bc, so minus of minus b will become plus b minus ca, so minus a. You really have to take care of the signs here, plus and minus sign, right? So this is the factorization. A minus b plus 1, a square plus b square plus ab plus b minus a plus 1, or you can leave it here itself. This is the answer, right? You just have to mention that you are using this formula and you have written this expression in this form already. So you use this formula and write it like this, okay? Now look at this question. If you look inside the bracket, right, if you say that a is equal to x minus y, let us say this is a, this is b, this is c. Now if you add a, b and c, it will give you 0. Why? Because these are in cyclic order, x minus y plus y minus z plus z minus x, x, y, z, right, x minus y, y minus z, z minus x. If you add these, all of these terms will cancel out, leaving 0. So sum of these, if you consider them a, b and c, sum of a plus b plus c is 0, and a cube plus b cube plus c cube will be equal to 3abc if a plus b plus c is equal to 0. So the factorization of this x minus y cubed, y minus z cube plus z minus x cubed will be equal to thrice of x minus y, y minus z, z minus x, right? Just looking at the question, you can directly write the answer if you know this formula well, and you can identify that what is written inside the brackets is cyclic in order, that if you add these, it will give you a sum of 0. Look at this one again. What is written inside the brackets, if you add these, what will you get? X will be cancelled, 2y can be cancelled, 3z can be cancelled, so it will be 0. If the sum of what is written inside the brackets in a sum of cubes is 0, then we can directly write it in this form: 3 into x minus 2y, 2y minus 3z, 3z minus x. This should be your answer for this question. However, I would recommend that you always consider it something, a, this as b, let us say this as c. Then you show that a plus b plus c, that is this expression, is 0. Hence, a cube plus b cube plus c cube will be equal to 3abc. This is what we have learned in this chapter. Hence this answer. Okay. So this was about this exercise on extra questions. I hope now you are confident enough to factorize various polynomials and use the algebraic identities in that factorization. Okay. Thank you.